Now if you see, so in the last video, we have understood in order to obtain off diagonal element ZQI, we need to know the voltages. In order to do that, we need to know the performance equations of the primitive network. In the last video, we have seen that. From that, I am continuing. This is the performance equation of a primitive network, where I bar is the vector of currents of different elements of the primitive network. V bar is the voltage vector, and Y is nothing but the primitive admittance matrix. Now, I am just writing this matrix equation by separating only the element PQ element and the remaining elements. For example, if there are 10 elements and I am separating one element out of 10 elements, writing one element separately and the remaining 9 terms separately, I can write like this. So this is a vector which contains all the currents. Out of all the currents, I divided it into two parts. This is only for the current through PQ element, and this is for the remaining all elements. Similarly here also, why PQ means the self-admittance of the PQ element. Why rho sigma bar is the self-admittance vector of the remaining elements. Why PQ rho sigma bar is the mutual admittance between the PQ element and the elements of rho sigma bar. That is the reason why we have this has no vector bar, this has no bar, but this has a vector. This is a vector. Similarly here also, only we are separating one element, hence you don't find any bar here. The remaining all elements have bar. And here also, as I am separating the voltages into two parts, voltage of PQ element and the remaining voltages. So I can write this equation from this equation of the primitive network. Now, from this matrix equation, in order to obtain the first element in the left side, IPQ, I can write YPQ, PQ into VPQ plus YPQ rho sigma bar into V rho sigma bar. Now, we know that IPQ is equal to 0. If you observe the partial network in the previous video, there we injected a current of 1 ampere at ith bus only. And we make that all the currents as 0 for the remaining buses. So, we injected a current at only ith bus, making all the buses as open circuited. That is the reason why we got IPQ as 0. When IPQ is equal to 0 is substituted in this equation, we got this as VPQ. And we know that VPQ is nothing but voltage drop between the element bus P and bus Q. So voltage drop means the difference between two voltages, EP minus EQ. So I just copied this. In place of V rho sigma bar also, as we write VPQ as EP minus EQ, we can write V rho sigma bar also as E rho bar minus E sigma bar. From this, in the last video, we have seen that ZQI can be equated to EQ. Similarly, ZPI can be equated as EP. So from that we got EP as ZPI and EQ as ZQI. YPQ rho sigma bar is nothing but the mutual admittance between the added element PQ and the remaining elements of the partial network. So it is YPQ rho sigma bar. So Z rho I bar, because as we wrote EP as ZPI, EQ as ZQI, I can also write E rho bar as Z rho I bar minus Z sigma I bar. Now from this, what I need? I need the off diagonal elements of the extra row and extra column. So if I know ZQI, I can automatically find ZIQ. So I want to write the equation for ZQI. Hence ZQI is equal to ZPI. If you send this term here, you will get positive sign. So plus YPQ rho sigma bar into this value. Now what is this means? YPQ PQ is nothing but self-admittance of the element which is added in between P and Q. And what is YPQ rho sigma bar? It is the mutual admittance between the added element and the remaining elements of the partial network. So in this way we can obtain the off diagonal element. Now I want to see the special case in this way of finding off diagonal elements. The special case is if there is no mutual admittance, if there is no mutual admittance between added element and the remaining elements of the partial network. If there is no mutual admittance between the added element and the remaining elements of the partial network in the problem, then we can neglect this ypq rho sigma bar, or we can make this as 0. In that case, what we will get, the off diagonal zqi as equal to zpi. Means if I want to know zq1, what I can do? Simply zp1 value is nothing but zq1. If I want to know zq5, for example, I can get it from zpi. From where I can get zpi value? From the already available bus impedance matrix of the partial network. I can get these values, zpi values. Just equate them to zqi, you will get the off diagonal elements of extra row and extra column. Okay, so in this way we can find the off diagonal elements. In the next video, we'll see how to know or how to find the diagonal elements of the modified Z-bus matrix. With that, we can complete the discussion on addition of branch. So, in these two videos, means in the first video, we have come up to the primitive network. In the second video, I continued from the primitive network. In these two videos, if you have any doubts, please post me them in the comment section. Or if you want me to do some more videos on some other topics, let me know from the comment section. If you like this video, or if you really understand these videos, please share and subscribe among your friends so that they can also understand the concepts of electrical engineering. Thank you very much.